I'll try and keep this short, guys. And if it, seriously, I'm happy for this class to be casual. If I'm like boring your brains out, just like raise your hand and be like, hey, we need a break. And I'll do my best. Same thing with like my speed. If I'm like flying through this and it's like, whoa, slow down, what are you doing? Let me know. Or vice versa. If I'm like this is where you click for this, you know, like be like, speed it up, we know this, okay? So again, my goal now is, there's really one main point I want to make with this goal. I guess a couple. One is to just cover, again, extrude and fillets. Very basic stuff, but the cornerstone of CAD. To build on that a little bit, though, I'm going to talk about my ideal workflow through CAD, and this will kind of introduce us to the model projects. And then the final point I want to touch on is multi-bodies. So when to use assemblies, when to put multi-bodies in a part. There's kind of like a lot of things here now. So I guess maybe let me open first the tutorial just so we all know what we're talking about. But then I'm going to build it from scratch. So this was the first part you all built. Now you can agree or disagree. I would say this is a relatively simple part. It is essentially 2 extrusions followed by a couple fillets. Oh, sorry, an extrude cut in the center, and then a command called shell. Okay. You can see it's a very short tree. Again, just to cover some of like the basics of what we talked about. So these are all features. These are all sketch tools. You can think of sketching is similar to Illustrator. This is the feature tree. Again, the analogy I used is that this is like a permanent Photoshop history on the left side here. Anytime you create a new feature, it brings up the property manager, which basically says like, hey, what settings do you want for this feature to have? Okay. So the one thing that I'm emphasizing with Project 1 is a practice called master sketches. A master sketch is a sketch at the top of your tree that everything else relates to in the tree below it. So if I were to start this project off, I have a drawing here in hand of like the dimensions of this. That's a lot quicker way to build than going through step by step. So first off, I would look at the build and think about where the most information is. As far as choosing which plane to build on, that's pretty much arbitrary. You can always think of the object in real life. So if it's like a car, you know, like the front plane would probably be where the headlights are. Hey, Daniel, how's it going? Okay, sorry about that, guys. As far as picking the planes, it typically doesn't matter. Again, this is just like a preferential thing. You can think about the orientation of the object. I don't know what this object is, so I'm picking the top plane. So again, the plane is like a piece of paper. We all installed my hotkeys last time when we worked together in the second half of class. I can cover that again. But so for me, I click on the top plane, I click on Alt-S to create a new sketch, and it orients the plane towards me. Now I hit R to create a rectangle. Hotkeys are always quicker. If you guys can learn the hotkeys, your workflow will increase exponentially. I hit L to create a line from one corner to another. There is a rectangle tool that defaults with a center. To me, that's too specific. I'd rather just create my own center tool. That's could be disagreed. I'll show you guys. I'm flying through this, but it's right here, center rectangle. I have mine default to corner rectangle because that's more typical of what I'm building. So now when I create these sketches, I change the different relationships within the sketch. So this angle through the middle, this is just to center my square around the origin. The origin is the fixed point in SolidWorks. So I'm going to click on this line and say just for construction. I don't want it to be like an edge or anything. It's literally just there for orientation. I'm now going to click on these two lines, holding Control, so I select both of them, to give a new relationship and say I want their length to be equal. That gives me a square. I now hit D to get the dimension, so I can actually type in exactly what I want this to be. Now, the drawing is in millimeters. There was a discussion last time about whether to do millimeters or inches. I said it depends. It depends on the clients. It's really personal preference, but the way to switch back and forth from it is in options up here. Go up here, document properties, units, and click millimeter gram second. And now in here, I can double click this to edit the value. I'm looking at my drawing, it says it should be 120, I type in 120. Then I click check to get out of that. So now I'm looking again at the features of the object. Like I said, it's essentially two extrudes. The other extrusion is the cylinder on top. I click on the center, I click O, which is my hotkey for making a circle. Click on the center, because that's how it starts. Escape. Now this one also has a value. I hit D again to dimension it. Click on this, and the value of this is 70 millimeters. Now I know I'm going to have to cut a hole through this. What I'm doing right now is I'm creating the master sketch. I'm creating all of the measurements that I need to create the part in one sketch. This is so that all the information is located in one area if you ever need to make an adjustment. If you reference this sketch for all of your commands, it's just a very tidy way to organize your build so that, again, if anyone is working on this model, they can go to the master sketch, edit that to change things, okay? I'm creating a new circle in the center. This one is 50 millimeters in diameter. And now I can exit out of the sketch. I could either hit this up here on the right or click on this sketch feature here. So again, this is the master sketch. You can rename it. You don't have to. Again, with a part this basic, typically master sketch is overkill. But again, for the sake of introduction and getting you guys used to this format, it's a good intro. So the way you use the master sketch, if I were to make a feature off of this, it would consume the sketch. It would become part of the feature. So the master sketch is something that's now in the tree, and the goal is to leave it at the top and to never consume it with a feature. So the first thing I'm going to do is extrude the base. So I'm going to click on this top plane again, Alt-S to make a new sketch, Alt-N to orient it normal to me. Again, this is my workflow. Now what I'm going to do is from the master sketch, I'm going to pull just the widest cube or square. So I'm selecting it all carefully. And then I'm going to click on Convert Entities. This is on that sheet. I refer to it as copy. This Convert Entities with sketches is something that happens very frequently in the master sketch technique. You have the master sketch and you keep copying features from it in order to inform the feature. Let me rephrase that. You copy parts of the sketch into new sketches and create features from those sketches. So now I have this exact width. It's built off the master sketch. I click on Extrude. I'm saying, hey, I want this sketch to be elongated. I now get my property manager on the left. This is asking how long do you want to make this. I'm looking at my spec sheet on how long I want to make it. It's telling me it needs to be 50 millimeters. I type in 50 in the length here. And then I can click check. These are all different options that you can ignore for now. Really, this is just asking how long do you want this to be. So there we go. That's a 50 millimeter extrude. Now I'm going to click on this face. So instead of creating a sketch on a plane, in this instance, I'm creating it on a face. We can get into deeper conversations about this, but essentially, like anytime you select something, so in this case, this face, if I build a feature on it, if this face were to disappear, if I were to remove this feature, it would leave the feature that this was based off of hanging, okay? These is like slightly more advanced stuff. You don't need to really worry about it now. But knowledge of having features refer to other features is often what leads to errors in SolidWorks when you make changes. Any questions on anything? Am I going like too fast, too slow? Okay. So again, I click on this face. This is the piece of paper I want to create the new sketch on. Same exact thing as before. Alt-S to say create a sketch. Alt-N to say, hey, make this normal to me so I can see it in a 2D view. I'm now going to click on this sketch because this is what I want to extrude. And again, I'm going to click on Convert Entities, aka copy. Now, same thing. I can just click straight on Extrude from within the sketch. And now I enter this dialog. I can look at the drawing, or if I'm measuring a bottle, I can measure it with calipers. Here it's telling me that it is 25 millimeters taller. So I'm going to click on 25 millimeters. I want it to merge. So now there's another body in here. This is saying, hey, is this part of the same part, or is it its own entity? So I'm leaving it defaults to merge result. I'm just going to leave that checked because I want it to combine. So then I click check. The next thing is we poke a hole through this. So like I mentioned, all of these features come in pairs. For every additive feature, there is often a subtractive feature. So here we have extrude. Now we want to do extrude cut. In this instance, I am going to take the top plane. Alt-S, Alt-N. Again, Alt-S enters the sketch dialog. Alt-N rotates it so it's facing me. I take this from my master sketch. Click on this inner circle. Click on copy. And now instead of extrude, I want to do extrude cut. And now I can drag this all the way through. That's another way to do this dialog. Or I can just say through all, meaning to say, hey, whatever this cuts through, cut through everything. Or I could set it defaults to blind where I type in a value and I can just make sure it's longer. Those all get me the same result. Any questions so far? Okay. Now, typically in the way you order a model, you always want fillets to be towards the bottom. That's just kind of a general best practice rule of thumb for tree organization in SolidWorks. The reasoning for that is fillets tend to be a final step. It's kind of like a final surface detail. So that's one reason to put it at the bottom. The other reason is it's something that tends to change a lot. Again, it's something that you can quickly say like, hey, I want the object to look sharp, or I want the object to look soft. So playing with the fillets can quickly change that. It's also something that, like, if you're working with someone else, you might get feedback on. So anything that you anticipate to change a lot, if you can put it lower in the tree, the better the chances are of having a robust rebuild. The reason is if you have something, let's say that you have a client and they say, you know what, we don't know how long we want this handle to be on this microwave. You might put the handle build at the very bottom of the tree, because what you don't want to happen is if the handle's at the start of your microwave build and then you base the door off of it somehow, just through relationships in SolidWorks. If you then have to change that handle, everything below it might fail. Is this all making sense to you, or am I like speaking Greek? Okay. It's hard for me to like have a game, like, I guess sorry, I don't need to make this clear. It's just like, I'm so used to the program, so it's like, I don't know. I'm relying on you guys to gauge me on whether it's like too in-depth or not in-depth enough. Okay. So that's just tree organization. So now at the end, I'm just going to drop these fillets in. So again, these are the most basic features: extrude, extrude cut. Fillet is another very basic one. We didn't really talk about it in any depth last class, but again, you guys should have experienced it within the tutorial. A fillet basically says like, hey, take this right angle corner, or I guess it doesn't have to be a right angle. Take this corner and create a tangency between the two faces. And you're telling it how big or small to make that tangency. So with these language, right, these are faces, that's a face, this is a face, this edge is a corner. Tangency means, the formal definition is touching but not crossing, for what it's worth. The way that I think about it in SolidWorks world and in my head is it is a smooth transition from one to another. So we all know that this is going to be shelled. You guys might be asking me, hey, I thought you said put fillets at the very bottom. Why aren't you shelling it first? Anyone want to attempt to answer that question for me? Why would I put fillets before the shell? Yeah, for the shape. So a shell, what the shell does, you guys, who wants to try and like verbalize what a shell does? Yep. Great. I would say the key there is that it hollows it out, but well, no, that was very well said. Both are important. It hollows it out to an even thickness. It's a very useful tool because most objects that exist in real life that we interact with, it's very rare that it is a solid body. Some things in this room that are solid are like the tabletops, right? That's so that it's sturdy and not flexible. But like the bottles that we all have in here, these are all shelled. right? Because if this was solid, that'd be no good. I could have my olive oil in here. This projector is hollow, right? There's all the guts inside. And yes, the reason that we put the shell last is if I were to put the shell here, we can just like look at this. Again, I'll look at my drawing. I think it's a 2 millimeter wall thickness. So again, you hollow it out to an even thickness, as Tom said. The thickness is referred to as a wall thickness. So again, this olive oil bottle has a wall thickness. I'm going to guess it's something around 1 millimeter. That might be too thick. Cut it in half and measure it. Anyway, this drawing is telling me to make this 2 millimeters thick. So what it does is it hollows this out. The face that you select with a shell is where it hollows from. So if I select this face as well, can you guys predict what's going to happen? Yep, both these faces will be gone. I can always edit this. I can, here in my dialog here, I can change the faces that are selected. I can do this one. We can see what that looks like. That's kind of weird, right? I don't know. Anyway, so the face you select is important. So you have it shell from the bottom. But now if I roll down to this fillet, it gives me an error, okay? This is what I'm talking about in getting, so in the tree, the order of operations is important. The reason why it's giving me an error is because the fillet, the curvature that I'm trying to put on this corner is going to eat in to the inside of this wall, right? So if I drop this down to 2, it shows me, it gives me this like wireframe. It says, hey, you can do that. As I slowly click up through increments, 3 lets me do that. 4 lets me do that. Let's see, it probably will let me get to like 7. No, 6. This is a game you're all going to play at some point in this class, is what is the largest fillet I can get on this corner? This is a very common game to play. There's more advanced stuff, but we won't get into it. Anyway, labored point, if I drag this shell now below here, now it fixes it. Because what it does is when it shells, it checks the outside surface. Now it can create an inner fillet that matches that. So in this instance, you want the fillets as low as possible. Sometimes you need other commands to go beneath it. Also, the order in which you fillet is important too. Let's see, I'll give you an example. So here the top edge is 5 millimeters. So now if I rearrange these fillets, let me see if I can think. Look at this nice corner here. That's a pretty corner, unless you guys disagree. If you disagree, I'll show you. Oh, I guess that's not. Oh, you know what? That's funny. Let me redo this. That's what I was expecting. Oh, it still works. Okay. The order in which you fillet is important. So here I just selected this edge, right? So now, because I drag this corner fillet below it, what happens is the fillet runs up, it turns here, and then stops on this corner. Whereas if I orient this beneath here, because these are all tangent to each other, if I create a new fillet, it's going to run all the way around, and I can select just this edge. You guys understand that nuance? Is this like super basic stuff, or does that make sense? Okay. The bottom line is, the way you orient your fillets, the order is important. The edges you select is important. Okay. Okay, you guys, it seems like you guys all get this. Let me just finish this off. You can select edges or faces for fillets. So if you select a face, it applies it to all edges on that face. Sometimes you can combine edges and fillets. If I know that I want this inner edge to be the same, I can edit this and select another edge. I think the tutorial had you guys like back out of it, deselect an edge, and then create a new fillet for the value. Type it in on this drawing what the value is, so I'm going to just make it up. But we'll just say it's 5 also. And then you put the shell in last. And now, again, here we should see, because all these fillets are on there, the shell on the inside is nice and clean. Cool? Any questions on that part? The most basic things is Shall fill it. So here, let's look at the master sketch. This is why master sketch exists. When I first started working in SolidWorks, my first job out of school, I was working for Troy. We did a lot of Weber grills. I was so grateful that my first project was to build essentially a square cabinet because it was just extrudes. But surprise, what happened to me is my boss comes, looks at it, says, you know what, could this be wider? And I didn't know SolidWorks very well at the time, and it's like, oh man, I have to rebuild this? Like, are you kidding me? I just built this. That's why I quickly learned to anticipate, again, what changes are you going to need to make, and build your tree in such a way that those changes can be made. Yes, I had to. There was a lot of, early on in working at Troy, there was a lot of time spent rebuilding something that, if I were experienced, would have been literally like a 5-minute change. Like, go to the master sketch, type in the new value, but here I am, you know, fresh out of school, so they don't care, right? Well, I'm sure he cared, but like, there was thankfully there was forgiveness in that they gave me however much time I needed to rebuild it, so I am grateful for that. But yeah, I mean, I probably would have done myself a favor. Like, again, maybe they wouldn't have expected much out of me, but like, can you change this if I were to go to my master sketch, plug in the new value, and it rebuilt right there? They probably would have been like, oh, that's great. We can give you something else to do now. But yeah, so to just illustrate that, right? So it's like your boss comes over. It's like, hey, what even do we think this is? It's like a block. It's like, hey, this giant Lego block thing actually needs to be bigger. You can then go to your master sketch, edit it, and it's like, all right, how big do you want it to be? You want it to be twice as big? So let's make it 240. Click that checkbox, exit out of the sketch, and then it rebuilds. Now again, with a basic model like this, you could also make that edit here. But if everything is all within the same dialog, it's just kind of this one place you have to go to change the main features of the part, it kind of simplifies it a bit. Okay. You can also Control Z throughout SolidWorks. Yo. Sure. So what the step you probably skipped was you didn't make a new sketch and you didn't copy the features from that sketch. That also happened. So this, like, yeah, using a master sketch to build, it often happens at some point you might end up, yeah, I call it eating the sketch. You may end up eating the sketch at some point. Try and be aware of it. Okay, this is a good problem solving thing to talk about. Let's talk about it. So here, let me, wait. How does this? You know what? Let me get back to that. I think, sorry, my mind, I'm trying to think this through right now. So I'll be honest, I'm totally mind blanking. I thought there was a way to say like replace sketch for feature, but now I don't know if there is. I know you can, so let me, if you don't mind, let me get back to that. Let me play around. For whatever reason, again, I'm drawing a blank right now. To just briefly talk through what my assumption was, is I swear there was a way to like create a new sketch and then say, tell the feature to say, you know what, use this sketch, not this one. But for some reason, I'm not remembering that, so I'm gonna play around and Google it during a break and I'll answer that question. But yeah, the gist of that is try not to let that happen. Try not to let, I think with let's see, with this, yeah, the master sketch, you shouldn't shouldn't touch. Correct. Now, I was also recently told, now this isn't my style, and again, I'm teaching you guys my workflow, right? I'm not claiming it's the best. And again, there is nothing best. There's going to be something everyone's going to find that works for them. Apparently, there is a new setting in SolidWorks in the last 2 years where you can have it not eat sketches. Some people may prefer that. I think that's how Pro E works. I don't know, but that would confuse the crap out of me because, like, sometimes, well, it is a pain that it eats the sketch because now the sketch is like kind of disappears. It is nice to know that if I go to this feature, I can see the sketches underneath here if I need to edit it. You could do that. It's not ideal, but I see what you're saying. Yeah, so like some things that happen too, and so here's a nuance for you guys. I don't know if you've noticed this. It's really small here, but you see how the sketch is blue and how this is gray, or like a thin black frame? This means the sketch. So another thing I keep toggling is Alt-V, which hides and shows us a list of things. It defaults to just sketches and like planes, I think. That's something useful, like if I don't want to see the sketch anymore, just to like observe the part, I can do that. If I want to see the sketch, I can view it. Now, the master sketch is defaulted to visible because it hasn't been used. Anytime you consume a sketch with a feature, it hides it. It defaults it to hidden. You can always right-click on the sketch and say, make this visible. So the reason I bring that up is if you accidentally use your master sketch in a feature, you could always right-click on the sketch and make it visible again and just refer to it, like you said your workaround solution was. And that's totally fine. Like that's a fine workaround solution. All right. Let me make my last points, which will probably take, I'm going to guess, another 15 minutes. And then we'll take a break. Unless there are any more questions on this part. Okay. So the last point I want to make, obviously the tutorial was not just one part, it was two. So the last like kind of major point I want to make is how to manage multiple bodies in SolidWorks. So again, terminology, this whole part is a body, okay? Like I showed you here, when I created a new extrude, it asked me whether it wanted to merge it. If I told it to not merge, not only are we going to get some errors and it's going to change the model, but now we have two different solid bodies in here. You need to say they're not connected to each other. Now, there's different ways to approach this. I'm going to tell you from my experience and what I typically see within industrial design SolidWorks usage, multiple bodies are always kept within the same part. It's just, it's like an efficient workflow thing that keeps like file management a little more simple. You can think of it as, you guys are all familiar with InDesign, right? You know you have links, you like import things to it. Have you ever shared an InDesign file with someone or had someone share one with you and they literally just gave you the file and none of the links and you're like, yo, like help me out here. Yeah. Now, same thing can happen in SolidWorks. I'll have a client that will send me, let's get into a new thing here. You guys got into it. It's called an assembly. An assembly is a combination of parts, okay? If I'm using this InDesign analogy, the part is like a JPEG. The assembly is the InDesign file. The assembly always points to different links that you have in there. Now, they all have their time and place. Assemblies, in my experience and in my opinion, are typically used more so by engineers, and they are typically used the further along you get in the design and development process, the more you're going to start to use assemblies. It's a more formal way to organize the part, especially when you get into manufacturing. Most of the work that I do for my clients is more so now as a freelancer. They more just want me to do form and CAD and kind of like more starting level stuff. They're not relying on me for manufacturing. They're going to rely on in-house and their engineers for that. It's also just not my bread and butter. But at Choi, like we did a lot of parts for manufacturing. That is when we got into assemblies. And if you guys are curious about all that stuff, if you want to nerd out about like manufacturing, I'm happy to bring in like some of those models at some point. But yes, when it comes to like workflow and just like literally designing within SolidWorks, assemblies become problematic for that link analogy that I gave, okay? Again, it's all up to you to decide how to work. So if you're going by the book would probably tell you to use assemblies. If you're going by like workflow and sharing files, my advice to you is to build multiple bodies within a part. It is very possible to break bodies out of parts. That's something we would also do, is like you might have this like master file with all the bodies in there. Now it needs to go to production. There might be a stage where you literally just, I refer to it as parting out the part, I guess. We called it parting it out, where you would like delete all the different bodies, you know, clean up the model a little bit so that you got the individual parts out of it. So it is possible to still use that file. Okay, so I created a new assembly. I inserted this part. Now, again, if you go by the book, here's one way to create a new part. You can say insert component and new part. And now what this is going to ask you is to say, oh, wait, this is weird. All right. It's going to ask you, like, where do you want to reference that part to? This is really weird to me. What's going on? Okay, sorry, getting a bit ahead of myself. Let me get out of this. So what happens when you put a new part into an assembly is you want to orient it to like, so just like a regular part file, the assembly has these default planes, which I don't know why they're not centered. It probably reverted it based on my part. But now when I go insert component, existing part assembly, it's again a feature dialog box. Oh, you know what it is? That's what it is. I said this. The one thing I always forget to do is to save. Don't make that same mistake. So this is a new part I built. I built it on the top plane. This is why I was confused. It looks like in the tutorial, they picked this to be the top plane. So again, it's always different. They had this, they built it off the front. The orientation is different based on how you see things. So let me just save this real quick as okay, so in this assembly, now I'm going to go insert component, existing part assembly. I want to insert the part I just built. Now what happens when I click on this and I click check, what it's going to do, it's going to take the part and align all of the main planes together. So top plane to top plane, right plane to right plane, front plane to front plane. That's the default. And that's why I was confused, because I knew that I built this off of the top plane, but the top plane was suddenly on the bottom. I inserted the wrong part. So now what you can do is you can insert more parts that exist by going here, or you can insert a new part, which is, again, this is another way to add a new body. And I'm showing you guys this just, again, to show you different options, and maybe to talk about some of the pitfalls. Now, the reason that you don't want to do this, why I advise against this, let me switch here. If I load this command manager, there's this big thing here that says no external references. So again, just to use my link analogy in InDesign, if the assembly is pointing to a different part, right? So right now there's two parts in this assembly, this one I built and this new one I'm about to create. If I don't have this checked, this external references, what might happen is when I build this thing here that says part 4, if it's pointing to some features on this model, it is now tied to that model. That's not a good thing for part strategy. Because now, again, if I make that clumsy mistake and I send you one but not both of the parts, the new part that's pointing to the other one is now going to have errors. So again, I'm just trying to tell you guys best practices. So everyone should have, and we'll do like a let's match some settings thing later on in the class. I think, again, everyone installed my settings, so everyone should have this no external references defaulted on, but we can double check how to turn that on. It is in options here somewhere. External references. So you always want this to say, do not create references external to the model. Again, it's just going to make your life easier in the long run. So again, you can build a part in an assembly. You want to make sure your external references are turned off. So now you enter into this mode where this is blue and this is a wireframe now. That's telling me that I'm building a new part. You'll see as I start to build this part, what it's going to do it won't be wireframe. That's how it's telling me I'm working on it. So now I go in here. Again, I don't want to make a mistake and click on the top plane within the assembly. I want to click on the top plane within the part. I see. It merged the front plane to it. That's weird. You know what? Okay, so I typically don't build this way, guys, but let me show you what I just realized. When you create a new part, it's asking you which plane is the front one, I believe. Yep, that's what it seems to align. So when you insert a new plane, when you insert a new part, whatever plane you pick, that's how you like introduce the new part. It's going to align the front plane of the new part to the plane that you pick within the assembly. Hopefully that's clear. Anyway, so now that I'm in this part, like I said, it's blue. I can now do all the same things. So Alt-S to create a sketch, Alt-N to orient it to look at me. Same thing, if I do Alt-V to turn hidden things on, I can now see a sketch in this other part. I can now pull this sketch as a starting point. I'm going to copy it, but it's going to tell me that because it's an external reference, it's going to break all of those alignments. It's going to tell me that 4 times because there's 4 segments. So I now have 4 lines that they're initially based off of this master sketch, but because I have this turned on, so it's not directly connected, it immediately broke all of those relationships, and now the sketch is blue. You guys should know, I forgot to mention this, a blue sketch means that it's undefined, which means I can drag it around. There's no definition to those lines. So now what I can do is I can apply some definition to them. I can make them equal in length so that it's a cube. I can make them perpendicular so that they have a right angle relationship. I can make this horizontal. So now I'm basically telling this square to be a little bit more fixed. Again, same thing. I want to center this. So I'm recreating a lot of the same stuff as before. So this is a construction line, midpoint, define this. And again, it's because we broke all of these external references. I can then continue to build this part within here. It's a blind extrusion. It's 70 millimeters long. Same thing. I can apply fillets to it. I'm trying to fly through this because I realize I've been talking forever. The fillet defaults, I think, to whatever the last value was. But again, I can look at here. And just for the sake of like simplifying this, I guess this is a 4 wall thickness shell. Now that this part is built, I know it's not quite finished to the level of the tutorial, but let's just cap it here. I can exit out, and now I have this new part. Now the last thing that I have to do is save this. So if I go File, Save As, it's going to prompt me, hey, you have a new part in here that's unsaved, or it should. Let's see. This assembly contains unsaved vital components which must be saved. Okay, this save internally, save externally is new to me. Let's just say save internally, see what happens. I'll show you guys what I typically do. I was expecting it to prompt me to save the part out. What I typically do if I create a new part in assembly, which is very rare for my workflow, is I right click on this and I say open part. And now I have just the part in its own part file, and I'll just save this out. So I'll just save as tutor 4. My whole goal in this was to show you guys that you can build a part within an assembly. to tell you guys why you might not want to, because you don't want to create external relationships. I'm not going to do it. I'm just going to tell you guys what I would do, again, for the sake of keeping it short. If it's me, I am building that new part within this part file and just not merging it. So now I don't have to recreate any square. I can go to the master sketch, click on this, right click and do select chain. That selects everything attached to it. I can copy that. I can extrude it, again, to the same 70 millimeters. This time I'm going to go the opposite direction because it's below it. I'm going to uncheck merge result. So now I have two bodies in the same part. I essentially did the same thing. Again, in my opinion, and what's pertinent to industrial designers, is 100% the linking and external referencing thing. That becomes a rat's nest when you're working with other people. And the reason why I'm specifying for industrial designers is more often than not, when you're working in CAD, you're still in a bit of an exploratory phase. You're not doing anything final. You're translating a sketch. You're figuring out some form in a little more detail. And to begin with, it's a better workflow to be within one part so you don't create external references. So these are two paths to the same end goal. One is to build this form within this part. If I hide this, you can hide bodies. The other one was to build it within the assembly. But then, of course, there becomes the issue of external references, which you want to turn off. But then I have to like redefine everything. And now I basically have this InDesign file pointing at two different parts that I have to keep together. Any questions on anything? Okay. I realize that was a lot of talking. Appreciate your guys' attention. Let's take a 15, 20-minute break. Let's say 20 minutes. Be back here at 15.